set your uh, daily target. And yeah, let's say 26th of January. Yeah, before 31st January, you make the target that you will complete all the chapters before 31st January, right? Before
Yes, sir.
31st January, you complete all the chapters of physics, complete all the chapters of chemistry and biology. And do you have maths also? Yes. Do you have maths?
When, sir?
Yes, sir. Do you have
Sir,
maths?
your voice is breaking.
Yeah. Do you have maths? What are the other subjects that you have? So you have physics, chemistry, biology, and then you have maths or any other subject? Yes. Yeah. Can you hear me, Nishita? Maybe my voice is lagging. What is happening? Can you hear me, Nishita?
No, sir,
Yes.
it is still lagging.
Oh my voice is breaking. I guess there is some internet issues at your side. I guess because my internet is working fine.
Okay, sir,
Yeah, maybe there are some internet
I'll
issues. So whatever
I'll
the
leave
four
this alone.
subject you have, please complete all these things. Yeah, please do that. Please, yeah,
So can you hear me properly?
yes, yes. Now it's okay. So I was telling that please take in your daily routine. Please take 3 hours of your time daily and give all these hours to these subjects that you have and daily set some targets, right? And before 31st January, you try to complete all those chapters. Start your
Yes,
preparation
sir. I took math also, sir.
now, right? Give everything, like, because you have only 1 month to prepare all these subjects, right? Okay, and yeah, so whatever the doubts would be, please, yeah, we can discuss. Okay, so in the last class, we studied about this collision, right? And then, yeah, so we did all the questions, right? Completed all these questions. And now we will move on to gravitation part, right? The system of particles that is the large chapter, and from the neat and JEE perspective, that is quite a lot, right? So we'll start about this gravitation part, right? But in the CBSA portion, whenever you have any doubt in system of particles, right? Right.
Yes, sir.
System of particles, what were the things that we studied, right? We studied about the, uh, yeah, so translation, in translation motion, we talked about center of mass and all those things we calculated, inertia and all. So similarly, for the case of this rotation motion, we talked about angular momentum. All, all. So yeah, uh, in the case of the system of particles, we had two kinds of equilibrium. One was this translation, the other was rotation. And then we talked about Jasola. That one is a big chapter, but in CPS question, if you then we'll talk about that. But today we will start gravitation. Right. So the first thing that we talked about three laws of Kepler, which were essential for the planetary division of the planetary motion is governed by these Kepler's. There were Kepler's law, right? And they were for planetary motion. So first law was the law of orbit. So they move in elliptical orbits, right? So the orbit is elliptical. I will not write all these things, but we'll just understand, right? And this ellipse has two sides, right? So one is in this side, the other one is this side. Let's say this is F2, this is F1. And at one of foci, the sun is situated. So sun is and this is the Earth, right? This is the evolution that gives you these years, right? The years that we celebrated is due Yes, I got it. Yeah, the disabled participation. Right. Okay, let me just text them to make me the post and then start. So we had three laws, Kepler's laws. One was this law of orbits. The other one is this law of so the other law is the law of periods, and the other law is the law of areas. Right? So all these things we talk about. Right. So this is the law of orbits. Right. And these are two peculiar points. So let's say the Earth is here. Earth is rotating, it is reaching here, and it comes at this place. So you see that this sun is here, and there are 2 points, this one and this one. Let's say this distance is r1, and this distance is r, right?
Sir, your voice is still breaking, sir. And
Ellipse ellipse has this point as which smallest axis. This is what is happening to be, because all the lights are green, right? Why is that? Okay,
sir,
internet is
your
unstable. Yeah, my voice. Yes, is it still breaking?
it's fine now, sir, but it
Yes.
goes and comes.
Yeah, yeah. Sometimes it happens. Yeah. Okay. And now it is fine, right? How is it
Yes, sir.
now? Ellipse, right? And this ellipse has this length, which is called the minor axis, right? This one is called the axis. So if we take this much distance, so this is called a semi-major axis, okay? And this, if we take this distance, this is called semi-minor axis, which is represented, right? And so A and B are the diameters of this ellipse. We have only this semi-major axis and this semi-minor axis, right? So A is the semi-major axis, and B is the semi-minor axis. Okay, so now let us come back to this point. So Earth is here, the sun is here, and now at some point the Earth is here. So which this one would be the closest distance, right? So this is the closest, which is called the perihelion, and this one is the farthest, and this is called the AP. So these are the 2 points of the Earth, right? The planetary motion of the Earth, these are the two peculiar points. Okay. And this one is the law of orbit, which says that the Earth moves in elliptical path, and this is situated at one of the foci of this law of area, and it comes from the conservation of angular momentum. So it says that the rate of change of area of change of area, right? So dA by dt, that would be constant. And if we take the same time, if we take same time interval, delta t, if this is same, then area 1 would be equal to area, right? Otherwise, we will have 1 by t1 would be equal to a2 by t. If this comes from the conservation of angular, right? Conservation of angular momentum says what? That the angular momentum is conserved, right? So this is the conservation of angular right? Let's say you are at perihelion and you are at aphelion, right? For the perihelion case, angular momentum is mvr, right? This is the angular momentum. So, this perihelion and this radius at the separation between the sun and this earth. So that is r field. And this is equal to mass of the earth again and this velocity at aphelion, the distance between the sun and earth at aphelion. This will cancel. So this will remain constant, right? And as you can see that if we write down Vp by V, that would be equal to Ra by Rv. So can you tell me from, let's say, this is the figure that we have, right? This is the sun, this is the earth at perihelion, this is the earth at AP, right? So this is the distance between the perihelion and this is the separation between earth and sun at AP. So which is larger, which one is greater? Can you tell me which one is larger?
Sir,
Which one is
uh,
larger?
RA.
Which one is the larger distance? RA or RB? Which one is greater? Absolutely correct. So RA is greater than. So RA is greater than RB, right? So if I take this thing in the denominator, so what will be remaining? What will remain here? If I
Sir, can you hear me? RP by RA?
So I guess might.
Yeah, it probably so.
Yeah, so today it is happening. Sorry about that, right? It's fluctuating a lot. Okay, again I have to text them. So I'm not right. Yeah, sorry about that. So the first law states that, yeah, now I, first law states about this orbit, right, which is the elliptical orbit. Second law states about this area that if we take the same amount of time, right? So if we take about the same amount of time, so it will sweep equal areas, right? And yeah, so I was talking about this point that if I take this RP here, so this would be 1, right? So if I take this RP, so this would be 1. And if we put this value RA by RP greater than 1 in here, so what we will get? We'll get VP by VA that is greater than 1. And if we take this thing in here, so VB would be greater than VA. So what is it saying? That when the Earth is near to this point, so its speed will increase, right? So the Earth will move this region with larger velocity, and this region with a smaller velocity, right? So if it covers right, so if it is covering equal area, then this would be the area that it will cover in this region, and in this region it will cover a smaller area would be same, but this would be right. This would be small in here, the speed would be large. Right. So this is what the law of area states. And this comes due to the conservation of angular, right? And we saw that this velocity here, this point of the Earth, so Earth will quickly larger. This is conservation of angular momentum. If we have equal area, then this would be the thing. If yeah, this is very bad. It's fluctuating a lot, right? I don't know why. Sorry about this, actually, right? So the law of period states that the time period of revolution square that would be directly proportional to the, this is the major axis, right? Semi-major axis and its cube. And if we assume to have, let's say that we take a significant figure, and in that significant figure that we assume that this is a radius, average radius, right? Average circular path. So then it will be t square would be directly proportional to r, the radius of that, right? If we assume that. So this would be the law, right? So these are the laws of Kepler, and combining these results, Newton gave the idea of, right? So what does it state? So it states that in here, and if we have the other mass, right, we will attract each other. either with some separation, let's say R. So the law says that some attraction between them, and that would be M1. Yeah, so this, let's say that the separation between them is R, right? This is mass M1 and M2. And all the mass would be weighted at this end, right? This again would be M1, M2 by R square. So we will always take the distance from the centers, right? If they have given the spherical form. So this would be the, please note it down and then we'll do some questions, right? So today's lecture is of 1 hour. There's no T2 hour here, so we'll do some questions based on this. Yeah, please note it down and then we'll do questions. And whenever you want me to scroll down the screen, please tell me. And today's internet is very bad, so please forgive me about that, right? Uh, Whenever you want me to scroll down the screen, tell me. Yeah, whenever you have noted these things, please tell me. Yes, Rishita, noted.
Done, sir.
Then please, uh, yeah, yeah. Whenever you have data, uh, this is for point mass, right? And this is for spherical. But for both the cases, you have to use this Newton's law of gravitation, right? So this is the T. I should write as time period. A is semi period x, right? And yeah, R is the averaged. If whenever you have noted that,
Done, sir.
then okay. So now let us start with a simple. This is based on the law of periods. Remember, you have satellites, right? And a geostationary satellite. So what is a geostationary satellite? Let's say the Earth is rotating on its own axis, and you have a satellite which is rotating the Earth also, right? So the Earth is also rotating, the satellite is also rotating, but if you fix the rotation of the satellite in such a way that it mimics the rotation of the Earth, then the satellite will appear to be stationary, right? Do you understand that part? Yes,
Yes, sir.
please. So then we matches the time period of that satellite to the time period of the Earth. And we know that the time period of the Earth, so Earth completes its revolution around itself is 24 hours, right? So the time period of the geostationary satellite, that would be also geostationary satellite, right? What are those? So time period, time period matches with Earth's revolution, which is what? Which is 24 hours. So the that is why this is stationary satellite. They appear to be stationary, although they are rotating, but they will appear to be stationary. Right? So these are called geostationary satellites. Okay, so we have this Earth, right, and its radius is RT, right, and then we have this satellite which is rotating this Earth. Right. And we know that this distance is how much? This distance is for the first case. This is the surface of the Earth, and this is the distance from the surface of the Earth. This is 6 RT. Right. So then, what is the R that we have? What is the R? The distance from the center. How much is that? That is 7 RT. Right. Is it clear?
Yes, sir.
Let's say this is the one satellite, right? And then we have this another satellite also at this position, right? And it is also rotating, but its distance is how much? 2.5 RP, right? And then this R2 distance would be how much? That would be 2.5 plus RE. So that would be 3.5 RE, right? So we have these radii, and then we have this time period. And what Kepler law relates the period with the radius? What is the law? What is the law, Shita, that relates the period with the time radius?
So can you repeat that?
So I'm asking that in this question you have these time period and then you have these radii. So what relates, what law of Kepler relates time period and this radii? What is the law? Which one? If you have three laws, so which among them relates the time period with the radii? Which among them?
Law of period.
Law, right? So the third one. What does this law states? The law states that the time period of
T
revolution
cube,
that would
T
be
square is
argued. Yeah, t square is argued. That is the law, right? Good. So one time period is given which is 24 hours, right? And the other time period that we have to calculate, right? But the law of period states what? So we have T1 square that would be equal to this R1 cube, right? And let's say this is some K constant, right? So if you remove the proportionality, that is K. Similarly, we have this T2 square that would be equal to K R2 cube. And if we divide these things, so what would be there? So this would be T1 by T2 whole square, that would be R1 by R2 whole cube. Is it correct? Right, because this is proportional.
yes.
So then, if we write, right, if we write all these values, so T1 is 24 hours, right? T2 we have to calculate this square, and then R1 is how much? 7 RP, and R2 is 3.5 R. So RE cancel and this is Q. 3.5 and this is 2, right? So this is 2Q. This is 24 into 24 divided by T2 square and this is 2Q. So if we take this T2 square in there, so this would be 24 into 24 divided by this is 8. So 8 is 3, right? So this is 72. So T2 would be root of 72. And how much is this? So this is 36 into 2. And root 36 is 6. So this is 6 hours. So this would be the time period of smaller one, right? So this is the other satellite. Is it clear to you?
Yes, sir.
Okay, then please do it. And you see that this will not be a geostationary, right? Because its time period is not 24 hours, right? It will move fast. Because at every 6 hours, it will complete its rotation. So it is moving with higher velocity. Whenever you have noted it down, and we will keep this class for 1 hour, right? Rest of the people are not here. Yeah, whenever
Done.
done. Okay, good. Then let us do the next question, right? And let us see what is the next question. So next question is about the kinetic energy, right? We have points, right? Okay. So we have kinetic energy of a planet in elliptical orbit about the sun at position ABC. AC is the major axis and SP is perpendicular to AC at the position of the sun as shown in the course. So we don't have any figure, so I will draw that figure, right? And yeah, so this is the elliptical orbit that we have, and this AC is the major axis, and this is the sun, and this is what? This is sun, and this is the point, right? So perpendicular AC is as shown in the figure, right? So let's say we have this point, and this point. So kinetic energy, this is the the progression of the kinetic energy that they have given. So we have 3 points, right? And you know that which one would have the largest velocity? Can you tell me which one would have the largest velocity and which one has the slowest velocity? That we have talked about, right? Yes?
AS will have the largest velocity,
Yeah, so VA is the largest, and then we have VB, and then we have
and
VB.
then we have VC.
So this is how the velocity is changed, right? And we know that the kinetic energy is dependent upon kinetic energy is what? Kinetic energy is half mv square. This is the kinetic energy, right? So at A position, this would be half m mass is same, right? Because this is the same planet which is revolving. Then we have this B at B, the kinetic energy would be, and then this is C, right? So this would be VC square. So as we can see that this one is the largest one, so this kinetic energy would be largest, right? So then what would be the correct, right? So this would be the correct proposition, right? So kinetic energy at A would be maximum, then we have B, and then we have so is it clear to you? Yes. Is it
Yes.
good? So please note it down. And you see that it was a 2 minute problem, right? 1 minute, in 1 minute we did this. Please note it down. So then, yeah, then we will stop at there. Yeah, like, whenever you have noted it down. So revise all your concepts, right? If we have our concepts strong, then yeah, these questions will be very. Whenever you have noted it down. Yeah, whenever you have noted it down. Yes, noted, Rishita.
Yes, sir.
Okay, so we will stop at here, and yeah, so you were telling me that you had some doubts in this rotation part. So what did we study? Right, so we talked about the
No,
first thing.
sir. I tell I will have doubts on rotation because it's like a very long chapter.
Yeah, yeah. So you have assumed that there would be some doubt. Yeah. So first go through the
Yeah.
notes, and yeah, please make your plan, right? Because nobody knows you well than yourself. So you make your plan so that before 31st January, complete all the chapters of different subjects, right? Then you would be able to, so then only thing that would be remaining in your subsequent exams that you have to repeat all those things again, right? So please make your target that complete all your chapters before 31st Jan, right? And that is not for the case of physics only, for maths, for biology, for this what, chemistry, right? So all these chapters, right? Okay. Farid has come, I guess. So we'll stop at here and yeah, see you in the next class. Bye, Rishita. Bye.
Thank you, sir. Bye, sir.
Bye. Bye.